Let us look into a few more examples of the locus. For example, if it says that there are two intersecting straight lines. These are two intersecting straight lines. Suppose AB, I'm taking segments or straight lines, you can take A, B, C, D. A two-line segment which are intersecting at point P. We have to find the locus of points which are always equidistant from these two intersecting straight lines. We have to find the locus of a point which is always equidistant from these two intersecting straight lines. The locus of those points is the angular bisector. For example, this BP and PD are intersecting at P. So if I bisect this angle, suppose I bisect this angle, then every point on this line will be equidistant from PB and PD. If I will drop a perpendicular, I will take a point here and I drop a perpendicular here, or I drop a perpendicular here, we'll find both the perpendiculars will be of equal length. Similarly, if I extended this back here, so obviously every point on this line will be equidistant from CP and PA. CP and PA. But the question is, what about this? The same will happen here. If I bisect this angle, then this bisector passing through P will, every point on this bisector, suppose this is, I said PQ R S T, then every point on the bisector RQ will be equidistant from these two intersecting straight lines, as well as every point on the line TS will be equidistant from the two intersecting line CD and AB, AB and CD. If you take this pair here, this point is equidistant from PB and PD. If you take any point on this line, anywhere, then that point will be equidistant from PC and PA. If you take any point here on this line, here, that will be equidistant from CP and PB, because if you drop a perpendicular from any of these points on these two straight line, they will be of equal length. Similarly, if I drop any from these points, any perpendicular on these lines, that they will be equidistant from PA and PD. So if there are two straight lines intersecting, like here in this case, but if the two lines are only meeting, for example, then they are making an angle only. Here they are not intersecting, they are meeting at a particular point. They are not intersecting each other, they are meeting at a point, so they are forming an angle. In that case, there will be only one line of locus. One locus will be there, which is equidistant from these two lines. That will be the bisector of this angle. The same principle is applied there. Because they are intersecting, then the four angles are formed. Here only one angle is formed. Here only one angle is formed, but here four angles are formed. So there will be, obviously this will be one locus, this is another locus, this is another locus, this is another locus. Basically there are two locuses only, and these two locuses are perpendicular to each other. They are perpendicular to each other. We will find that this line RQ and ST are perpendicular to each other. RT and SQ are perpendicular to each other. So this is another condition of another locus problem for you, that if there are two intersecting straight lines, to find the locus of point which are equidistant from these two intersecting straight lines, the locus is the bisector of the angles, the angular bisector. The angular bisector is the locus of all the points which are equidistant from these two intersecting straight lines. This is also very important, and it will be used for construction in your class too much. Then I'll be doing questions, quite a few questions will be dependent on this. Now let me talk about Another very important locus, which I have already discussed because I have already done circles with you. Most of the circles have been done. All the theorems corresponding to circles have been done with you. Please go through. On iSchool website, there is assignment support. On top of the assignment, my videos are there for class 9th, 10th and 11th. And I have done for 10th, a lot of work in that, for 9th also, and for 11th also. You must go through those videos, and if you have a problem, you write back to me. I'll be ready to help. I'll be ready to sort out whatever you want to understand. You want to revise something, you want me to do something, though Mr. Sembal is doing everything, but even then, in case you need me to do something, you let me know. Now let us see the next important locus, very important. Let us see the next locus, which is also very important, which is the definition of circle. What is the definition of circle? I've always discussed this, that we have to find the locus of a point such that this is a fixed point, suppose somewhere. This is a fixed point. And I want to find the locus of a point which moves such that it always remains at a constant. It's a constant distance from this point O, suppose. This is point O. I have to find the locus of a point which moves. Path will be only obtained when point is moving. If it is stationary, there is no path. So when the point moves in such a manner that it is always equidistant from this point O, we have to find what is the locus. The point is moving like this. This is actually a circle. This is a circle. I'll tell you how. This is a circle. This locus is the circle with O as center. With O as center. Any point P is here. The distance between O and P is whatever. Suppose R is there. If I move P here, again I'll find PO is the same R. If I take another point here, suppose let me take a Q point, let me take R point here, OR, then let me take OA, OB, OC, OD. You take the point anywhere on the circumference of the circle, you'll find the distance of point P, Q, R, the distance of the point P, Q, R, A, B, C, D, and many other points. Any other point which you take on the circumference of the circle will be at equal distance from point O. So, the locus of a point which moves in such a manner that its distance always remains constant from a fixed point. Fixed point is called the center of the circle. Fixed point is called the center of the circle. Here, O is the center of the circle. This P point, Q, R, A, B, C, D, these are moving points. These are the points which are moving. And what is the manner in which it is moving? What is the condition? What is the geometrical condition which it is fixing these points? That the distance of these points, should always remain same. Always remain same from O. That means if it is 4 centimeter, I'm just taking an arbitrary number 4, it is not necessary that radius will be always 4, then all these distances, whether it is OP, whether it is OQ, whether it is OR, whether it is OA, whether it is OB, whether it is OC, whether it is OD, this all will be equal to 4 centimeter. These distances will be always equal to 4 centimeter. 4 centimeter means same. 4 centimeter means same. The meaning of saying here is 4 centimeter means the same distance. I had taken R, but just to make it more clear to you, I have taken up another fixed number because it is always easier for you to understand with numbers rather than alphabets. I have seen that children always correlate with numbers more than with alphabets. So OP is equal to OQ is equal to OR is equal to OA, OB, OC, OD is equal to 4 centimeter. 4 centimeter is also not fixed. It could be 8, it could be 2, it could be 1.3, it could be 1.5, anything. So the locus of a point which moves such that its distance remains constant. Constant means fixed from a fixed point. Constant is not changing. Constant is not changing, which doesn't change. So from O, the distance of P, Q, R, A, B, C, D, if it remains the same, then this point P, the locus of point P will be a circle of radius 4 centimeter. This is very important. Now, another circle problem. What is the another circle problem? It says there are two concentric circles. When I talk of the concentric circle, that means the circles with the same center. The two circles have the same center. When see concentric means they have the same center. These are two concentric circles which have got the same center but different radius. Suppose this is R1 and this is R2. These are two radii, different radius. We have to find the locus of a point which moves in such a manner that it will always remain at a fixed distance, equidistant from this circle as well as this circle. Find the locus of a point. Find the locus of a point which will always remain at same distance from both these concentric circles. Now, it is certain that that locus will also be a circle. But what kind of a circle will that? Will be also a concentric circle. That will also be a concentric circle. And what will be the radius? You just add R1 plus R2 divided by 2. You divide R1 plus R2 by 2. That means you will have to draw a circle which is somewhere in between, equidistant between these two circles, with the same center. This circle which I have drawn with dotted lines, the circle which I have drawn with the dotted line is a concentric circle or the locus of a point which are equidistant from these two concentric circles. This distance and this distance will be same. This distance and this distance will be same. This distance and this distance will be same. Now, we have to find, third one is, we have to talk about another circle problem. Suppose this is a circle and there are equal chords drawn here, equal length. Suppose this chord, this chord, this chord and this chord. All chords are of equal length. When I say chord, this is AB. Chord is AB. If any 2 points on the circumference of a circle are joined by a straight line segment, that is called a chord. For example, this is CD, this is CD, this is EF, this is GH. Now, if I join, what will be this locus if I join the midpoint of all these chords? If we have to find the locus of the midpoint of these chords, equal chord. Equal chords are always equidistant from the center of the circle. That is the property of the circle. That means if I take this here, O is the center, and if I drop a perpendicular here, OP, then this OP, and if I drop a perpendicular here, OQ, then number one, it will bisect the chord. Number one, it will bisect the chord. It will be perpendicular, will always bisect the chord. If I show a perpendicular draw perpendicular here, OR on OS, then I'll realize that all these OP, OQ, OR, OS will be of same length, because equal chords of a circle are equidistant from the center of the circle. Equal chords of a circle are equidistant from the center of the circle. If I take OS center and OQ as the radius and draw a circle, that circle will pass through the midpoints of the equal chords of the circle. That circle will pass through the midpoint of the equal chords. So this is the locus, or the locus is a circle with the center of the circle and radius equal to the perpendicular distance to those chords, equal chords, perpendicular to those equal chords. These chords are equal. AB is equal to, you can say AB is equal to CD is equal to EF is equal to GH. This is the property of a circle, that equal chords of circle are equidistant from the center of the circle. If we drop a perpendicular from the center of a circle to any chord, it bisects the chord. These all properties we have discussed. These all theorems we have done. We'll continue doing this in the next video. Thank you.